Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. Tonight we'll be doing an absolute beginners session for people who've never seen Python before. This will be a similar session to one we've done before, but the point about doing these as live streams is that you get to ask questions, and so we can respond for you. We'll be using Google Colab tonight, which means that you don't need to install Python on your computer. We'll just be running it on one of Google's servers. Now, I've provided a link that we can use. I've put it on the Meetup page, and it's also in the YouTube page. So if you're watching on YouTube, just scroll down into the comments and you'll see the link here that you can click on. I'll be following chat on the Slack channel, Learning to Code, and if you look in the comments below in YouTube, you'll see how you can join that chat session. I'll also try to keep an eye out on the YouTube chat, but it's not always reliable in coming through to me. So if someone sees something on the YouTube chat, maybe post it onto the Slack channel as well, and so I can respond. So let's get started. You can see the link here on YouTube or in Meetup. So if you click on that link, it will take us to Google Colab, and it will give us a copy of the notebook that we're going to work through today. Now, if you want to make changes to this, then you need to make a copy of it into your own Google area. So you will need a Google account for this. You should see a button here saying copy to drive. So by clicking on that, that will make a copy of it for you. So there's my copy of it, and see, it's got to put the word copy of in front, and it's got a new URL. Now what I'll do, I'll share this URL as well, so that you'll have both the original one, which has got no answers in it, and this one will have all the answers as I type them in as we work through. So this link I'm going to post onto Slack. And I'll see if I can get it on. It's saying I'm not logged in at the moment. Oh yeah. And I'll post it there as well. So that's the chat session for the YouTube. Okay. So what you should see on your screen should be pretty similar to what I'm seeing on my screen. And all right, so let's start working through. So today we're going to learn about interactive Python. So interactive Python is a Python that we can run line by line, so it interacts with us as we work through it, and that can be really easy to see, really helpful to see exactly what's going on. We're going to look at a few of the data types that come with Python, such as integers, floating point numbers, strings, and lists. We're going to see how to create variables, assign values to them, update them. We're going to see how to write Python scripts, and we're going to look at a few program structures like conditionals and loops. So this should all become clearer to you as we work through. You've got your Google account. If you want to run Python on your computer, then I suggest you install Python from python.org. Or you could install from anaconda.com. So Anaconda is really for data scientists and people who like a lot of the third-party libraries that don't come with the standard Python. But even with the standard Python, you can install those third-party libraries manually yourself, which is what I prefer to do. You can also use an integrated development environment such as PyCharm Community Edition, which is free, and it helps you when you're writing programs because it shows, it can identify mistakes that you're making early on, and it helps you just keep everything organized. I've also got a children's Python coding course, so you go to pythonator.com. It'll teach you how to write Python code while playing in a game of Mind Test, which is just like Minecraft. Okay, so let's have a look at this Google Colab. It's made up of cells, and each cell you can have text in a markdown language, or you can have Python. So this one here at the top is actually a text cell, and this one here is a code cell. And you'll see at any point you can add another text cell or add another code cell in there, and so that's really good if you want to try something out. While we're working through these, you can add these code cells yourself and text cells. When we look at Python, these are 3 lines of Python code here, and they all start with the hash sign, and that means that they're comments, so they're just ignored, but it's useful for writing stuff in there if you want to remind yourself of why you've done something in a particular way, or give little notes about what the code does if it's not particularly clear from the code itself. So what I'm saying here, first of all, I'm telling you what comments are. They start with a hash. Then I'm saying you can use the question mark in IPython to bring up help. So at the moment we are running IPython, which we're running in a Jupyter Notebook on Google Colab. So all of these things, Google Colab, Jupyter Notebooks, IPython, they're all almost synonyms for each other. They're all very similar, and that's called interactive Python. So that's what the I in IPython is. Now everything that we run here will work, or most things will work in normal Python. The question mark won't. That's about the only thing that you see here that won't work is the question mark, and that is a way of bringing up help. So we've typed just a question mark on this line, and we need to run the cell. So we can press either this play button here on the cell, or you can see there it tells you what the keystroke is, and on this Windows machine it's Control Enter. So if I press Control Enter, it runs it, and the very first one we run in a Google Colab notebook is going to be slow because it's setting up a whole Python environment for us. But after we run the first one, then other ones are going to be quite quick. So you can see it's running here, and it's brought up some help here for us. So it's telling us about IPython. It's an enhanced interactive Python. It tells us some of the things you can use. For example, question mark on some word that you don't understand, and it will give you some information about that object. And you can also type double question marks and gives you more information. So I'll just close this now. So please ask questions. If there's something that I'm doing too quickly, you're not keeping up, I'm happy to go over any of it again, and you can ask questions. The questions don't even have to be relevant to the content that I'm going through, because like I say, this is a beginner's session. It's really just to get us familiar with playing around with Python and getting comfortable with using it. Alright, so let's look at variables. Variables are memory locations to store data. So we've got some data, so it could be some numbers or some text, and we want to store it somewhere. So what we do is we give it a name, and we store it at that data location has got that name, and that name is going to be called a variable. So for example, if we want to use the name A, and we want to store the number 3 in it, we say A equals 3. So it takes the data, which is a number 3, and it puts it in a memory location that it's labeled A. So whenever we want to look at it later, we can refer to it by A, and it will bring back the 3. So let's run that cell so that it will actually do it. And we can see it gives a little tick here, quickly ran the cell, and it stored the value 3 into the memory location that's labeled A. Now if we want to see what's in that memory location, we just say print A, and this will work in both Python and IPython. And so now I'll do Control Enter to run, and you see print is showing us the value of that variable, which is the number 3. Now, a special thing you can do in IPython is to see the value of a variable is you just type the variable name. This code will work in Python, but it won't display anything. So if I do Control Enter on that one, once again it gives us the value 3. So you should be able to press Control Enter on your computers, or I think on Macs it'll be like Shift Enter or Command Enter. And you should be getting these same results, and you can put in extra cells if you want to. So for example, you know, I could put an extra code cell in here, and I could say B equals 4 and Shift Enter, and that's just stored something into B. So fantastic. This is a fantastic system for experimenting, and that experimenting is a great way to learn the language. So I definitely encourage it. All right, now we can look at expressions. So we've got a variable called A, and we have an expression here which has got A plus 4. And so 4 is what we call a literal value. We've just written the value exactly as it is, and A is a memory location or a variable. So we're adding a variable to a literal value, and we want to see the results of that. And because we're using interactive Python, we can interactively get that result by pressing Control Enter, and it tells us the answer is 7 because it knows that A is 3, and it's added 4 to that. It gives us the value 7. I'll just check the YouTube chat, nothing on there. Now we can also write expressions and save the results of those into variable locations. So here we'll use B, which we've used before, but we'll use it again. And this time we'll add 15 to A. So 15 plus 3 is 18, and divide by 4. So we should get about 4.5. Now you remember before when we stored something in A, it didn't tell us what we wanted, but we can actually put another line here and say, now that we've stored the value in B, tell us what's stored in B, just by putting B on the line there by itself. Or if we were in normal Python, we do print B. And there we go, the value of B is 4.5. So these variable names, you can name them anything you like, except for a bunch of keywords. Now Python's got a few keywords, and in this next cell I'll show you how to get that list of keywords. They've actually got a library here which we can import and get the list of keywords. We can also work out what version of Python we're running by importing this sys library, and sys has got a function there to tell us what the version of Python is. This is all pretty advanced, so don't worry if you don't understand this at the moment. But what I'm really trying to show you in this cell is how to find out what the current keywords in Python are. And so this is them: false, none, true, and. So these are all names. You can't call your variables these names. They're the only names that are restricted, and they're called the keywords. So there's 35 of them in Python 3.7.11, which is the version of Python that Google Colab gives you. So if you were to install Python 3.8 on your computer, you'd find it says 35 there. It adds async and await. In fact, so they got added in version 3.7, so they're in 3.8 as well. You can see them there: async, and await. If you had Python 3.9, you'd see one more. It'd be 36 keywords because they've added this one here called peg parser, which is just a temporary keyword they've got in there. It's got all these underscores in front of and behind it, and it's just there to for people using 3.9 who need to know what parser. Now you'll never need to know what that is, but I'm just talking about it because it's here in the list of keywords, and when you get to 3.10 it won't be there anymore anyway. All right, so let's have a look at some of these keywords. So none is a keyword. So let's, and what it is, it's a value you give to a variable if you don't want to have any value. So we can say n equals none. What's in n? And the value is, in fact, there we go. It's got no value, nothing displayed when we said what's in n. And really, that's all that none is. And I'll show you how to use none in places. So it's similar to null in Java or nil in other languages. Yeah, it's just a value, no, when there is no value. All right, there's another keyword there called pass. Just like none is no value, pass is no action. So if you're wanting to write a line of code in Python that does absolutely nothing, you just put in the word pass. And it seems strange to have a whole keyword dedicated to doing nothing, but you will find in Python that there are times when you will need that. It's not needed in other languages. So no op is, you'll see that in some languages, but most languages don't have a command like this that does nothing. So if we just run it, it does nothing. So that's not very exciting, but we've now handled 2 of the keywords. So like I say, there's only 35 keywords there, so let's see if we can get up to half of them in tonight's session. All right, so our variable names can be longer than just A or B or N. You can put in a long variable name, and the convention is to use all lowercase for your variable names and separate each word by using underscores. And it makes it's quite readable. Since I started using it, I've quite like this convention that Python defines. But you don't have to. You can use your variable names like you do in Java or JavaScript, which are often camel case or something like that. Okay, so yep, a long variable name stores the number 345, and we can retrieve that variable name there. Now, if you use your variable name, if you use it, it's the same as a function or a library or something that's not actually a keyword, it will let you use that variable name, but you have to be careful because you will stop that function or library being available then, because you've renamed an existing function or library to be just a variable. All right. Now in our variable A, we've stored some data, and there's a function here called type, which will tell us what the type of that data is. So when you want to run a function, you put the name of the function there, so type, and then you run parentheses after the name, and that says I want to call the function, and I want to pass a value to the function, so I'm going to pass the value of A, and you can see Google Colab's helping me there and telling me that A is an integer with the value 3 in it. And I'm going to run this function type, and it's going to tell me what the type of the value is, and it's telling me that it's an integer. So if you ever need to find out what type a value of a variable is, you can use the type function. You can do it on variables, or you can do it on literal values, like 456 is an integer. Remember B we calculated before to be 4.5. That's not an integer, that's a floating point number. So floating point numbers have a fractional point that is, and the fractional part is represented, is the part after the decimal point. So floating point numbers are stored with a mantissa and an exponent, making it possible to store very large, very small numbers in a small amount of memory. The position of the decimal point floats through the number depending on the value of the exponent. So if I've got this number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's quite a big number, 0.0. And by putting 0.0 at the end, I was told Python that I want it to be a floating point number. It represents that it only likes to show about 17 characters, and if that can't show the whole number, then it will show it as this mantissa, which is this bit at the beginning, and the exponent 19. So that's 1.234, etc., times 10 to the power 19. And that 19, that tells me where the decimal point is in that number. So if I had another number such as this, which has got lots of zeros in the front, that's stored in pretty much the same way, the same mantissa, but just with a different exponent. So it's just saying that the decimal point's in a different place. Okay. All right. Now we also like to store, as well as numbers, we like to store text. So text is just a bunch of characters, and text is stored in Python 3 as Unicode characters. In Python 2 they were stored as bytes, and really in this modern age, bytes are not suitable for storing all the different characters in different languages around the world. So Python 3 was definitely a welcome relief to be able to store strings with Unicode characters. To tell you that you're using a string, you put the text with quotes or quotation marks around it. So you can use single quotes like I've done here, or you can use double quotes like I've done here. And they're pretty much equivalent. The reason you would use single quotes is if you've got a case where you want to put double quotes in the actual string. So if you started the string with double quotes, then you had a double quote in the string, it would get confused about where the string actually ended. So by using a single quote at the beginning, it makes it very easy to embed double quotes into the string itself. Other languages, you have to escape the double quotes if you started with single quotes. If you've started with double quotes, you'd have to escape any double quotes that you wanted to have in your string. Similarly, if you want to have single quotes in your string, then you can start with double quotes. Now there are going to be times when you're going to want single and double quotes in your string, in which case you can use either a triple single quote to start or a triple double quote to start. And that way that this string here doesn't end until it comes to 3 double quotes in a row. So we've created some strings here. These ones, which is just with singles, a single quote or a double quote, they can only be 1 line long. You can't press return in the middle of the string. But when you start with a triple single quote or a triple double quote, you can have embedded line feeds into the string itself, as you can see here. You've got to be a little bit careful as you've done it when you do that, and we'll see by printing them out. So let's print them out and see what it looks like. So here's our strings, they all look good, and then this one here, a string in triple single quotes can have embedded, and then line feeds, the L comes underneath the space in. So you can see it's kept all this white space here, all these spaces here are kept in the string. So if you don't want them to be there, then you need to start the second line back at the beginning of the line, like I've done in S4. And there we see there's no white space at the beginning of line feeds. All right, and if we did a type on any one of those S1 to S4, they would all come back as an str, which is Python for string. So if you're understanding that all really well, you've come from a different language, I can jump in and just show you a little bit more advanced features, which is how to look at how to put special characters into strings. So you can, if you want to put a new line, \n, put a carriage return, \r. If you want to put a single quote and you've started with single quotes, you could do \single quote. Similarly for double quotes, you can escape that. And if you want to put a \, in there, then you have to escape the \. So let's print those out. I'm using a different form of the print command here, where I just put lots of values I want to get printed and just separate each one by a comma. And when that gets printed out, it'll separate each one by a space. So 1 and then space, and then it printed a new line. So I jumped down to the new line. Then I did 2 and then a carriage return. So you can see the number 2 here, and then carriage return takes us back to the beginning of the line, and then it does a space, and then it does the number 3. So you can see we've overwritten the number 2 that got printed there. Then we've done our single quote, and then the number 4, our double quote, and the number 4, and our backslash. Sometimes this escaping can be a bit confusing. So Python has the concept of raw strings, which is this one here, and it's really in front of the quotes. You put the letter R and just say, that just says I want a string where my backslash is just a backslash and nothing else. And so I can do, if I wanted to put all these values into a string, I don't have to think about escaping backslashes everywhere. And so that's what an R is, and that's really useful if you're doing regular expressions, because that has lots of backslashes. And when you're escaping backslashes and then regular expressions have to escape backslashes, you can get lots and lots of backslashes, as I've found when I was doing this in Java. But in Python we've got the raw string, and it makes it a lot easier to achieve this result. What other prefixes can we use? We can use a U to tell it it's a Unicode string. So this is the default in Python 3, so it's not required in Python 3, but you can use it in Python 2 if you want to use a Unicode string. And similarly, if you want to have a byte string in Python 3, we can put a B out the front, which is the default in Python 2. We've also got format strings. Format strings are incredibly useful. So if you put an F there, then any time it finds these curly braces inside the string, it'll replace what's inside, it'll evaluate what's inside the curly braces. So if we want to, in this case it looks at the variable A and evaluates that, and it'll return the number 3. Then in this case it'll look at B, which is between those curly braces, which is number 4.5. And in this case it'll actually even evaluate an expression and return the result of the expression, which is 4.5. So if I run that, we can see our string. So it's printed out a Unicode string. It's printed out, when it's printed out the byte string in Python 3, it's gone. I'm going to print this out differently just to make sure that you realize it's a byte string. So it's going to print the B out the front and put single quotes around the whole lot. You can see our raw string has all the slashes came out just as they are. We didn't get new lines or returns or tabs or escaped single quotes or escaped double quotes. We got actual backslash single quotes and backslash double quotes. And here's our format string, and you can see the 3, the A got replaced with a 3, the plus just came through literally, the B got replaced with 4.5, and A plus B got replaced with 7.5. So let me know if I'm going too fast, and also if you've got any questions. So let's have a look at some of the things we can do with integers. We've worked a bit with integers, so let's store an integer 27 into the variable A and integer 5 into the variable B. And we'll look at all these operators here. We've got the plus, the dash, the asterisk, double slash, percent, and double asterisk. And I'm going to make use of format strings here so that I get a nice display. And you can actually, we've got all of these code as well as on Google Colab. We've got it in GitHub as a straight Python script for running for people who don't have a Google Colab account, or they want to run it on Python on their computer. And so I've used print statements here so it looks a lot better for them as well. So here we go, 27 plus 5, and that returns the value A plus B, 32. So that's just addition. The dash is subtraction, 27 minus 5 is 22. The asterisk is multiplication, 27 times 5. The double slash, so we've got an integer and a double slash, and that's called integer division or floor division. And so that says 27 divided by 5 is 5 remainder 2. So we can use the double slash to get what that quotient is, which is 5, and we can use the percent to get the remainder, so the modulo. And finally, the other operator is asterisk asterisk, which is the power. So 27 to the power 5 gives us this number here, which is 14,348,907. So that was really interesting. What happens if we change one of those values to be a floating point number? So let's change the A to 27.0 and run the same things again. And we'll also look at this operator here, which is the single slash. So we're getting the same results as you'd expect, but this time it's returning floating point numbers. So you can tell they're floating point by doing you can see the 0.0 at the back here, and here it was just 32. And if we ran the type function on these results, we'd see that these are floats and these are ints. And the new one that we put in here, which was the single forward slash, that's just normal floating point division. So 27 divided by 5 gives us 5.4, and really it doesn't matter that whether A is an integer or a float and B is an integer or a float, it will always return a floating point number when you use single slash. Double slash returns the whole number, but it's as a floating point number, not as an integer. And similarly, the remainder returns a whole number, but as a floating point number. And similarly, power gives us the same value, but as a floating point number. Now, if anyone's interested in some other operators, there's some called Bitwise Operators. So these work on binary numbers. So let's just have a quick look at them. This is pretty advanced for beginners, so if you don't understand what's going on here, don't worry, you'll never use it. I'm just showing you that it's there in case you come across these operators and wonder what they are. So we've got this vertical bar, which is called the pipe operator. So 10 pipe 3 returns 11, and so you can yes, so I've just got a question came through, is does 27 divided by 5 give the same as 27//5? And so let's try that out. It does, but it's always good to try it out. So if we say 27 divided by 5 and run that, and we can see that gives you 5.4. And if we add another code cell, we can say 27.0 divided by 5, and that also gives us 5.4. And we can even, although we'll be looking at it more later, we can say we can compare those two. Are they equal? And the answer is true. They are equal. So yes, it gives the same result. All right, let's look at these bitwise operators. 10 in binary is 1010. 3 in binary is 0011. And you put the bitwise OR in front. So that just means if either of them have a 1, then it's a 1. So you combine that 4-bit number with this 4-bit number, and we get this 4-bit number here, 1011, which, if you convert that back to decimal, will give you the value 11. And you can see here I've used format strings, and I've done some fancy things. So everything in a format string, anything after a colon, is the format of how I want it. Now I'll quickly run through these formats just so you know that they're there, but don't try to remember them. So greater than says I want it right justified to 2 spaces. Colon 4 means I want it to be 4 spaces long. By default it's left justified, so that one's going to be left justified, and I want it displayed as a binary number, not as a decimal number. Similarly, this is, I want it right justified, 4 places in binary, and I want it padded with zeros. So you can see there's a lot you can do with these format commands. So what have we got? They're all using those same things, just right justified with the right arrow, and B for binary. And you can put D's in there for decimal if you wanted to see them as decimal. Okay, I think I'll leave that for the moment, because you really will never come across bitwise operations unless you're doing data communications at a low level. There's a couple of times you'd use it, but certainly not as a beginner. So let's look at strings. So strings are text, but we can use operators on them as well. So we can use the plus operator for adding 2 strings together, and we can even use the asterisk for multiplying strings. So here, let's see what this gives us. So we've got well times 3 plus 3 holes in the ground gives us well 3 holes in the ground. So it's the plus has added this string to this string and together, and this string here is this string here 3 times long. So that's how we get one well 3 holes in the ground. In Python, adjacent strings don't even need the plus sign. So if you're looking at stuff and you're wondering how it's working, that's why it's working. I would always put the plus sign in myself. But there are times when you might want to have adjacent strings. You can just have some white space in between them, and it will just join them up. Possibly if they're on different lines, that's a case for doing that. Alright, so some of the interesting side effects of the way these data types work. Integers can actually have more significant digits than floats. So floats are limited to about 17 significant digits, and so you can have very big floats and very small floats close to 0. But the amount of space that they take up in the computer is going to be always the same. And so you are limited to the number of significant digits you can get. However, integers will expand to the number of digits that you want. So you could have integers that are hundreds of digits long, and Python will just store all those digits for you. So it'll take up a reasonable amount of memory, but it will do it for you all without you having to worry about it. So for example, let's have a look at this. So E, I've got 25 and lots of zeros. And then if I run 25/7, so that's the floating point division, I get 3.571428 and so on. So about 17 decimal places. However, if I keep it all in integers and don't go to floating points, I can actually get a lot more significant figures. So let's take this long number and use integer division with a 7, and here it is, 3, and I'd have to manually put the decimal point in if I wanted to actually use this as a way of calculating 25 divided by 7, and 3.571428, and it just goes on and on and on and on. And so you can see that the integers can store more decimal places, well, more significant figures. It doesn't store any decimal places, but then you can manually work on the decimal places yourself. So for example, I've seen people who write code calculating pi to 1,000 decimal places would do it all using integers, so they get that functionality out of Python. A problem with floating point numbers is they can't store decimal numbers exactly. This is great for science. I mean, it's great that we've got floating point numbers for science, but it's not so good for accounting, where they want the sets to always add up. So you've got to be a little bit careful if you're using Python and floating point numbers in an accounting context, because they will not always add up. But there are ways to work around that. Just be aware that they exist. One of them is using this decimal class, and the other one is just doing everything in integers and only converting it to dollars when you're displaying it. So let's have a look at this. If I've got 1.1 plus 2.2, let's see what that gives me. And that gives me 3.30003, and that's because floats don't store decimal numbers exactly. And they're stored in a binary form, which is why they can't do that. So binary is base 2 and decimal is base 10. All right, now we've got a challenge for you all. So the first challenge was just getting Google Colab to run. I presume you've managed to do that. So the second challenge is to try to work out some of these tasks. So the first one, have a go at yourself. If I'm going too quickly for you, just pause the video so you can have a go yourself, and then restart the video up again, maybe at 1.5 times speed, so you can catch up to where I am, and have a go. Otherwise you can just watch what I do. So if I want to add 123 to 456, I just put a plus sign between them and press Control Enter, and I get the answer 579. Okay, find the integer quotient and the remainder when dividing 666,666 by 235. Okay, so this is two results that I want to get. So remember, in a one way I could do it in interactive Python is I could have two cells and just put in the expression that I want. So the first one is what the quotient is divided by 235, and the second one is what the remainder is, and I wanted the integer quotient there, so I should have put a double slash, and the remainder. Another thing you can do in Python, I think he's putting it above, but is you can put both of those things on the same line and just separate by commas. And it will give you the two results separated by commas. It'll actually put parentheses around it as well. Okay, calculate 2 to the power 10. So remember, the power is the double asterisk, and 2 to the power 10 should be 1024. Yep, 1024. Find the decimal quotient of this number divided by 235, which is what we did before. And that's that number. All right, anyone having any trouble with that? Okay, the next task. Store in a variable the name of your favorite programming language as a string. Okay, so let's call my my favorite equals Python. All right, I've done that. Construct a new string that starts with programming in, finishes with is fun, and includes the value of the variable in the middle. Okay, so I won't actually save it anywhere, so I don't need to put a variable name out at the beginning. I'll just evaluate it. I'll put in the two strings, and I'll put my favorite in the middle, and it goes, programming in Python is fun. Alright, so let's have a look. Here are the solutions that have been provided using print statements and format strings. So yeah, we just add the two numbers together. Here we used integer division and modulo for the remainder. So we did the powers, that's the floating point division, and there's the string manipulation. So let's run this cell, and it prints out the full details of what we've done. All right, so let's look at another data type called Boolean. In Python, that's abbreviated to bool, and that's just really a true or a false. And remember, in our list of keywords, we had two of the keywords where one was true and one was false. With these, they've got start with a capital letter. That's important. And so we can find out what the type of either of those is. And they're both bools or Boolean values. So what a Boolean is the result of a conditional expression, not really conditional, or just an expression. And so we use the double equal sign to say, is the value on the left equal to the value on the right? So let's try that. And yes, that is true. They're both the same value. So 5 minus 2 is 3, and 3. So that is true that they're equal. We can use greater than or less than, or we can use greater than or equal to, or less than or equal to. So this is a greater than one. Is 45 greater than 23? True. Minus 10 is less than minus 20. That's false. Okay, because if you sorted them in ascending order, minus 10 would come after minus 20. Does C1 equal Python? What do we put in C1? C1 equals Python, yes. Let's see, that should come true. And it does. All right, challenge 3, predict the outcome of the following Boolean expressions. Okay, so I'm just going to run this because it'll print. Oh no, we'll look at them in here and we'll see, and then we'll run it, and that'll give us the answers. So C1 equals Python. Actually, I will run it because then we can explain why it got the answers that it did. But if you want to have a go at it yourself before, just pause the video and have a go at trying to understand what each one of these is going to return, and then look at what it actually does return. Okay, C1 equals Python returns false. Okay, so C1 is Python, and it's got a capital P, and we were comparing it to Python with a lowercase p, and so that returned a false. So for this equals to be true, they have to have the same case. It's a case-sensitive comparison for strings. We can do a check for does not equal, and that'll return the opposite of what equals returns. So C1 does not equal Python with lowercase p, returns true. So that's your symbol for does not equal, and that's your symbol for equals, the two equal signs. 253 is greater than or equal to 1518 divided by 6. That is true. So 1518 divided by 6 is 253 exactly. So because they're equal, greater than or equal does return true. 253 is less than or equal to 253. That returns true. So you can use equality between integers and floating point numbers, and if they are the same number, the same value, then they'll return equals, and you can compare them whether one's greater than or less than the other. You don't have to worry about converting them both to be floating point or both to be integers. All right, here we've used some of the values out of the math standard library. So to use that, we've imported the math standard library, and we've used the value of e, which is your exponent value, and the value pi. And we can see is e less than pi, and that is true because the evaluated e is 2.71828 and pi is 3.14159. There's another one in the math library called tau, which is really just 2 times pi. So e is less than 2 times pi is less than tau. Actually, that's what we've got, and that returns false. So you can see we've actually strung a few of them together, so they all have to be true for the answer to be true, but this comparison here is not true, so the whole answer is false. We can also compare characters to see whether one character comes before another. So lowercase a is less than lowercase c, that is true, and it's comparing the Unicode value of those. What becomes interesting is when you start to compare lowercase and uppercase, because lowercase a compared to uppercase c returns false, and that's because all the uppercase characters appear before the lowercase in Unicode. Similarly, you can do words. Upper is less than lower. Once again, that's true because all your uppercase characters come before your lowercase ones. Catch is less than carriage. This is alphabetical order, and they're all lowercase. So that would be false because the T here is not less than the R there. You can even do that with a list of numbers. We haven't looked at lists yet, but this is a list in square brackets. 5, 1, 2 is greater than or equal to 6, 0, 2. That returns false. It just does it the same way that strings are compared. It just compares the first character, then compares the second one, and it keeps comparing until it finds one that is different, and then it will evaluate which one is greater than or less than the other. Right, so we've been looking at operators here. Double equals, does not equals, greater than or equals. Another operator is in, the word in, and it's actually one of our Python keywords. So we can look at a string and see if one string is inside another. So for example, at is in catch, and that returns true. So that's basically saying the string at is in the string catch. But if we did the same thing with the string AC, even though both A and C are in catch, they're not adjacent letters, and so that string is not a substring of catch. So that one will return false. And similarly, TA, they are adjacent but they're in the wrong order, so that one will also return false. Now you can do that with strings, but you can't do that with lists, so just letting you know. So 2, 6 not in, 5, 1, 2, 6 returns true. So even though you'd think 2, 6 was in that list, when you're looking at lists, it only compares, you can only check for one element, because what it's doing is it's looking to see, does that list exist as a single element in here, which it doesn't. So not in returns true. You can combine these statements using ands and ors. And so and or are both extra keywords. So we're learning a few more keywords of Python here. So true or false, that's just the logical way that you think about those. That'll return true. But similarly, true and false returns false. Because you need, for an and to be true, it needs to be true on both sides of the and. For or to be true, just either one or both has to be true. Now it gets a bit more complicated when you start stringing them along. So for example, true or false and false, that returns true because and has precedence over or. Now I can never remember whether and has precedence or has precedence, so I would actually put parentheses around it to force the order of operations. I can remember for mathematics that the multiplication and division happens before addition and subtraction. So in those cases I probably wouldn't bother putting parentheses around, but Python does enforce that order of operations, so you need to know what that order of operations is to make sure that you use it correctly. Let's have a look at this one. False and false or true. So and has precedence, so we do that first. False and false is false or true. So on the left of the OR we've got a false, and on the right we've got a true. So either one is true. That's true. We get true as the answer to that one. Okay, and now there's one more keyword, just really letting you know it's a bit more advanced, so you wouldn't normally use it in as a beginner. C1 is C2, returns true if they both refer to the same location in memory. So that's more than just having the same value. That means they're both actually using the same location in memory. So just letting you know that that's there, and there's some important times when you would want to use that, but we won't get into that today. All right, so we've had a quick look at lists. So let's see what we can do with lists. We define a list using square brackets, and we separate a bunch of values with commas, and the values can be of any data types. So here we've put in a string, we've put in an integer, we've put in a float, and a bunch more strings. And we put the square brackets around them and stored it all into a variable called LST. Now, remember how I told you before, when you're using variable names, try not to use the names of built-in functions or libraries. Then list is actually a built-in function, so we don't list, so don't call your variable list, because you will end up with a debugging problem that will take you forever to work out. So I just call it lst, because that's a different name and doesn't clash with list. And there we go, we print the list and it shows us our string, our int, our floating point, and our other strings. So we can refer to any member of our list using an index, and we put the index in square brackets, and it starts at 0. So it's like C languages and Java, they all start their indexes at 0. And so if I say list 0, it's the number 6. If I want to know what list 1 is, it's 5. You can see there. And list 6 should give me 0. Now, one thing that's really useful in Python that you don't see in many other languages is you can use negative indexes. And what a negative index does is it counts back from the end. So where positive indexes count from the beginning, negative indexes count from the end. So if we're here and we count back -1, we'll get 0. So list -1 is ZERO. And there it is. Similarly, list -2 is ONE. So there's a function here called len, and that'll tell us the length of the list, which is how many elements are in it. So he's counted them before. There were 7 elements. 1, 2, 3, 4, 5, 6, 7, and that's what len is telling us. There's 7 elements. A nice shorthand for looking at a part of a list is called slicing. And so inside the square brackets we can put 2 values and put a colon between them, and it will take all the values from the first value to the last value. So it'll start at index 2 and go all the way up to the value that has index 5, but it won't include the value at index 5. And that last bit can be a little bit confusing for people. The way I think about it is the indexes are actually refer to the positions between the values. So 0 is pointing at the start of the word 6, 1 is pointing between 6 and 5, 2 is pointing between 5 and 4, 3 is pointing between 4 and 3. Okay, so if I want to go, give me all the values from the slice 2:5, I say all the values from 2:5, which is 4, 3, 2. So let's have a look at what 2:5 gives us. It's 4, 3, 2. And similarly, you can do the same thing with negative indexes. So if you go back -1, -2, all the way back to -7. So if I wanted to do the same thing, if I wanted 432, I could use -5 to -2. So let's give that a go, see if it works. Yep, that gave me the same thing. All right, when you're putting in your slices, you can leave the first number blank, and then it'll just start at 0 by default. Similarly, you can leave the second number blank, and it'll go from the value that you want you're starting at all the way up to the end. That's particularly useful because you can't actually put -0 in there, because -0 is the same as 0, and so Python doesn't recognize -0 as being different to 0. So that's the only way to refer to the last element, to going past the last element. You're going to put 2 colons inside your square brackets, and that way you'll go up from a starting value to the finished value, and the third number here is the step that you want to go up in. I haven't been showing you the results here. So let's say all the way up to 4, that's good. From 3 onwards, there those. And we want to go from 1 to the end, stepping up in 2s. So that's 5, 3, 1. So here's a fancy thing. We're going to start at the end, go up to the beginning but not include the first one, and we're going to go in steps of -1 and 0, 1, 2, 3, 4. So we've gone from -1 up to, but not including 1, which is 5, and gone in -1s. So it doesn't actually work in my little picture here. Alright, if I want to see the original list, it's still there. There. Okay. Now I can actually change any one of the values in the list by using this notation. So if I want to change the one at index 2, instead of 4.0, I want it to be FOUR. I can assign it using an equal sign. And let's have a look at what list looks like now after doing that. And you can see the 4.0 is replaced by FOUR. Similarly, I can do that with negative indexes. And I've replaced the 0 with blastoff. You can delete an element from inside the list using the del keyword. So there's another keyword we're using. So we delete list 3, and you can see that's the one from here, and now it doesn't exist when I look at list. Right, so strings, we've looked at strings before, and strings are very similar to lists in some of the things that you can do. So for example, you can do slicing. And then we get D, E, F, G. All right, so let's have a look at what is something you can do in a list that you can't do with a string. Okay, so let's see, what do we do? I guess we can go through all the things we've just done with lists. So let's have a look here. I'll create a new code cell. I'll just do one down about here. Okay, so let's create our string. So it's got the same number of elements in the string. And let's see if we can look at the character at index 0. And we can. There's the A. Let's have a look at the character at index 1, and that's B. So yep, those things are working. 6 G. Yeah, so that's a way of referring to individual characters. Can we find the length of our string? Yes, 7 characters long. So that's all working. Let's try, I'll jump down a few places. And we'll create a spot here. Let's try looking at characters 2 to 5 in our string. That worked. C, D, E. What about negative indexes? Do they work? Once again, we get C, D, E. Yes, that's looking good. An index, an implied index for the start of a string. Yep, so 0 is by default. And can we go from the third all the way to the end? D, E, F, G. Yes. Can we go up in 2s from 1? Yep, B, D, F. That worked. Can we go backwards from the end? -1. Let's go all the way. -1. So that's given us the whole string backwards, G, F, E, D, C, B, A. And that's a useful little way of reversing a string if you need to. Okay, well, all these list operations are working on our strings just like they did for the list. Let's try here. So now we want to change the second, the character at index 2 to a different character. So at the moment its value is C. So let's change it to Z. Alright, so there we go. I found something that string objects don't do. The string object does not support item assignment, and so I got a type error from Python. So that one doesn't work, that won't work. Let's try deleting the third character. And the string object doesn't support item deletion. Okay, so that doesn't work either. So where are we in our list? List, delete list. There it is. There. Okay, so we've written, I've put a solution here. Let's run our solution and see if it came up with the same as us. Yep, we can do all of those things. But if we try to assign a value, it returns a type error. And if we try to delete a character, it also returns a type error. And that's because strings are what we call an immutable data type. Immutable means it can't be changed once it's in place. So you can assign S to a new string, but you can't modify S in place. Or you can't modify any string in place. You can only assign it to a new value. Alright, now because of these similarities between lists and strings, it's actually possible to convert a string into a list using the list function. Remember I told you about this function before. That's the one you don't want to lose by calling your list L-I-S-T. So our string was A, B, C, D, E, F, G. And let's have a look at the list that we can get by running the list function. And I must have redefined S. Yes, I did. S equals 6543210. And now it's been split up into all those characters. Now you can use the string function to convert back again, but what you'll get back is a different value. So that's the string you get back, which is really not what you wanted in most cases. So what you would do, this is an advanced topic here, is you can use join to return to your original string. So you can take an empty string here, so double quote gives us a string that's 0 characters long, and I want to use that as the joining character between each of the elements of this list. And so let's see what we get when we run that. And that's the string 6543210. All right. So we're looking at a few data types now and operations. Now it's time to look at some programming. So let's write. So when you're writing a program, you can just put a bunch of statements one after the other, and that will be your program. However, it's not going to be a very interesting program because it will just do the same things to the data every time it runs through. Sometimes you want to make a decision based on what the data is, so that the program does different things in different circumstances. So for example, if we wanted to roll a die and then work out whether it's even or odd, we'd work out whether if it was even, and then we'd print this roll was an even number, and if it was odd, we'd want to print this is an odd number. So the way we would do that is using an if statement. And this is what an if statement looks like. So we roll the die using the random. Now random is a standard library that comes with Python, but it's not available unless you import it. So if we import it, we type import random up here, and then we can use any of the functions that are in random, and one of them is rand range. And rand range 6 will give us a number between 0 and 5 inclusively, and just pick one at random. And now we're doing a die rolling, so we're going to add 1 to that, so we'll get a number between 1 and 6. Okay, then we're going to look at that number and we're going to calculate what the remainder is if we divide by 2. And if the remainder is 0, then we know we've got an even number, and if the remainder is 1, then we know we've got an odd number. So we put an if statement in here, which is if was one of our keywords. We calculate whether it's even or odd by putting in a statement that returns true or false. And then if it's true, it runs what is this code block below it. And if it's false, it'll then do what else. So else means do the things that we, because it's not true, we'll do it this way. And a code block in Python, and this is really important, is indented by 4 spaces. Well, it's indented by spaces. The number is conventionally 4. If you've just using Google Colab, I think Google Colab might actually default to 2. So if you were typing and you press a tab, it might just put in 2 spaces, and that's going to work for you as well. But I've done 4 spaces because that's conventional Python. And at the beginning of the code block, we've got a colon. So if you see a colon at the end of the line, that basically says next is going to start a code block, and the code block is going to be indented, and the code block's not going to end until it finds some other code that's not indented. So it goes all the way up to else, and now else is not indented, but else is starting a new code block because we put a colon at the end there, and in that code block we've indented it as well. So if I run this bit of code, it'll say you rolled 2, which is an even number. Okay, and I can do it a few times and see how it goes. You rolled 4, which is an even number. You rolled 5, which is an odd number. So this gives us a bit of power of things we can do. Now sometimes we want to be a little bit more a little bit more complicated, our if statements. So for example, we had 2 dice that we're rolling. Then we might want to check the conditions, whether they're both equal, or the first one is less than the second one, or the first one is greater than. So in this case, we start off with our if, and we check if they're equal. And you can see how we've done here. We've used a list to store our dice rolls, and we've put an expression here to store the first dice roll, the first die roll, and an expression here for the second die. And we separated them by commas and put square brackets around. So that gives us our list. So if they're both equal, we use double equals. If the first one's less than the second one, we want to print versus less, and else, which is all other cases, then all other cases must be the first roll is greater than the second roll. So 6-5, first roll is greater than the second roll. 4-2, first roll is greater than the second roll. 5-4, they're always getting the first one greater. There we go, first roll is less than the second roll. And 1-1, they're both equal. Alright, so we're going to quickly introduce some loops. I'm not going to tell you everything about loops, but just letting you know that they're there. Loops in Python, like you can have for loops and while loops. For loops look a bit different to other languages in that they have a variable here that takes each of the values out of some iterable sequence. And so a list is a great iterable sequence. So in this case, we just put a bunch of values, and each time it goes through the loop, it stores that value in that variable, and then the next time through the loop it stores the second value in the variable, and the third time it'll store the third value. So if we run this loop, here's our code block. It started a code block with a colon here. We've indented 4 spaces, so that's everything that's going to be looped. And if we run that, it prints 3, then it prints 2, then it prints 1. Similarly, we can use a while loop, and a while loop has an expression, so it's a bit closer to an if statement, and if that's true, it'll do what is the true thing, and there's our code block, and inside that you can have other things that have code blocks inside them. So we've put our if statement, else if, else inside with each of its code blocks, and so all of this is in the while code block, and this is in the if code block, this is in the else if code block, and this is in the else code block. So it's going to roll the dice 10 times and print the results. So let's see what that looks like. There we go, there's the 10 times, 0 to 9, and we've got some less thans. We didn't get any greater thans. This is unusual. And we've got a couple of equals. So let's run it again. Yeah, this time we've got a few greater thans, a few less thans, and 1 equal. Okay, our challenge 5. Write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. Okay, so use the following list. So here we've got all the names of the numbers from 0 to 20. So I can do a for loop. So I'm going to create a new variable called number, and it's going to iterate through each of the values of the list of numbers. Then I need to yes, so I also need to know its value. So what I'm going to do is I'm going to iterate I'm going to go I haven't used the range. No, okay. There's a way I would normally do this, but because we haven't learnt it yet, and this is a challenge that you're supposed to do. We'll do it using things that you know how. So let's start I equals 0 for number in numbers. So the first number, 0, is going to correspond to 0 here. If I modulo 2 equals 0, then it's even. So we want to print every number as digits and its name in words. So it's going to be I number and whether it's even or odd. So that's going to be even. Else print I comma number odd. For number in numbers. Oh, I didn't run this one. So you've got to run this cell, otherwise it doesn't save it in numbers. And there we go. 0. And I also need to increase I by 1 every time I go through the loop. So there's I, 0, 1, 2, 3 up to 20. There's the name of I in a word, and there's whether it's even or odd. And hopefully all of those things you've learnt tonight, so that's how you should be able to write that program. So here's a solution using a while loop. So I started off with I equals 0, just the same way I did. While I is less than the length of numbers, well, that works. And then the category, so we stored even or odd in the category, and then we've printed that out. And then to increment I by 1, you can see I've used the syntax I equals I plus 1. You can also use I plus equals 1, which does the same thing. So let's just see how that works. And that looks good. Okay. Now we'll get on to a little bit more advanced stuff just to finish off. We've just got a couple more things here to finish. We're going to look at this decimal library, which is a standard library that exists mainly to help you with accounting type applications. So we can import that library, and once it's imported, then we can use it. So the way we use it is we create these decimal values by passing in the number with its decimal places. Now we can't pass that in as a floating point number, because once it's a floating point number, we've lost the precision and it won't be exactly 1.1. So decimal has been designed to take strings in, because 1.1 as a string is definitely the characters 1, a decimal point, and then another 1. And from then it can work out that where the decimal point is and do exactly 1.1 as a decimal. And so we can add those two numbers together. And remember, we got 3.30003. But now if we use the decimal library, we've got a decimal 1.1 plus a decimal 2.2, and the result of adding them together is a decimal 3.3. Now that's a fair bit of typing there. So there's another keyword from, which means we want to import decimal, but we only want to import this one class. So we say from the decimal library, import just that class, and then we can use it on its own. We don't have to refer to it as the decimal class out of the decimal library every time we want to refer to it. So let's run that cell, and that looks the same as the result, and so it's just been a lot less typing for us for every time we want to do that, and you'll want to do that several times through your program. And then sometimes you want to use it quite a lot in your program, and so even typing decimal is a long name. So we can use another keyword here, as you see all the keywords are coming up in this purple color, And so we're going to import from the decimal library the decimal class, but we're going to give it an alias, another name, just capital D. And that way we can just write D1.1 plus D2.2, and the answer to that is still decimal 3.3, but because that's just the way it displays. But if you want to use it, you would always have to use just capital D, because that's how we've imported it. And that's pretty common. You'll see for people in data science, you'll often see import pandas as PD, import numpy as NP. To show you that that works. All right, so these are all the keywords that we've covered. So I've put them all into a string here, all separated with these vertical bars. And I said split up the string based on the vertical bars, just to show you another thing you can do. Let's see how many keywords we've covered. And we covered 18 of the 35 keywords. So in your first session of Python, you've covered more than half the language. You've got 18 of the keywords under control. You know how to use them. So now it's just a case of learning the other ones and the other parts of Python. So that's it for me tonight. I hope you've learned something. It's quite a lot to take in. So, you know, maybe look back over the video. Don't maybe the first time go through the whole video in one hit, unless you felt comfortable. If you've been used to other programming languages, then you'll probably be comfortable just running through the whole thing in one go. Next week, we're going to be looking at writing scripts, Python scripts on the command line, and how to run them on the command line. So we're looking at things like how to run it, how to so put a script together, look at the output from a script, look at how to redirect the output from a script, look at how to pipe input into our script, and we'll also be looking at how to make a command line program that can take command line arguments and use them to do something useful. So we'll be able to write a program that will do something useful that can be run from the command line. And that's where Python is used quite a lot, is writing these command line programs for useful things to do. So after that, it'll be a bit more advanced than what we've done tonight. Tonight was designed for absolute beginners, but you're still welcome. Even absolute beginners are welcome to come along, and really we are trying to cater to the beginners, so they're able to ask questions of anything that's to do with Python, and we'll try to answer them. Okay, Leo has a question when I'm free. If after that, the following week will be Arun. He'll be doing a couple of weeks of machine learning. So if that's where you're interested, he'll be covering data science, machine learning, artificial intelligence, deep learning, that sort of stuff. So I look forward to seeing you then, and thank you for following along. If you like what we're doing, click on the subscribe button, or click on the like if you just liked tonight's video. Thanks. Bye.